In this video, we're going to learn how to add a new process method to a cognition model. If you're going to create an entirely new cognition model, you would use the Flames component copier as described in another video course. But in this case, we're not going to create a whole new class, a whole new cognition model. We're just going to add a new method. We're going to add it to the model that we've been working with, the EXM cognition model. And our convention is to put one process method per file. So the first thing we're going to do is actually create a new file for our new method. And normally what we do there is we'll take an existing method that's maybe close to something that we know we need, or if we don't have one that's close, it doesn't really matter because we can easily remove the insides of a process method. So we're going to take this existing assess method and we're going to just do a save as. And we'll make sure it's in the same folder, and we're going to call our new command set sensor range. So we're going to name the suffix of this file as something that's close to that. So we'll call this EXM cog, just like all the other files in here, and we're going to call this set sen RNG for set sensor range. And then I'm going to change a couple of things in here. I'm going to actually change the comments at the top. And I'm going to call this guy set sensor range. The return value and inputs, of course, are always the same. I'm going to change the comment here. Set the max range of the sensor attached to this unit. And then I'm going to take this name right here and I'm going to just paste it down here at the bottom just for comment purposes. And I'm going to hit save. So now I've got another file for my new process method. And before I change anything about the insides of this particular method, I'm going to make sure it will compile and link correctly. So let me copy this name, and I'm going to go to my class definition, and I'm going to just copy one of these existing specifications and paste in there the declaration of my new method. And this should be everything that I need to be able to build. So, one more thing, sorry. I'm going to right click on my filter in my Visual Studio solution, Visual Studio project, and I'm going to say I'm going to add an existing item. And I'm going to navigate to my EXM cognition, and here's this new file that I just created, set sen range. So I'm going to add that to my project, and now I should be able to build. So let's just see what happens. So it's going to rebuild the entire project since I added a new file to it. So fortunately it built successfully. So one of the things I like to do is compile and link often so I can catch a mistake early. So now that I have the sensor range in here, the set sensor range, let's go back to the actual file and let's change some things about it. So the input that I'm going to have is, I'm just going to call it sensor range. And I'm going to change this to I'm going to call this max range. And so I'm going to change this. And I don't need those two guys. And I'm going to take this print statement out of here for now. And what I'm going to do is, instead of querying for this first target ID, I'm actually going to set the range on the sensor. Now remember from a previous lesson that the sensor that we're using on this particular unit is a sensor that's a member of the EXM sensor class. And so let's go take a look at the attribute methods of that class. So I'm going to go down here to F equipment, F sensor. So here's EXM sensor, and here's the attribute method. And he has an alter method, and the alter method supports one variable called max range, and it has to be a real type. So if you call alter with a value of max range, you can set the max range of the sensor, which is the same value that's on the user interface. So I'm going to copy that name right there, and I'm going to go over here, and I'm going to say, I'm going to set the max range. And I'm going to pass in the max range. And this is not going to be get f integer value, it's going to be set f integer value. And I need to take that ampersand off the beginning there. And I'll just change my comment here. The max range of the attached sensor. So for now, I'm going to take the insides of this out. And I'm just going to do a Control F7 to see if this all compiles successfully. And it does. Now I've got a warning here that says that, oh, I've got the wrong function here. So I'm not setting an integer value. If I go back over to my attribute, it's actually a real value, as I mentioned just a second ago. So when I call f entity set f integer value, it's the wrong one. I need to call f entity set f and that's the reason I got a warning, is because I wasn't passing in a real value there as an argument. So as you know from an earlier course from the entity model development, there's a different set f entity set value function for all of the different values that are supported by MAL, all the different data types. So let's compile this again and make sure I don't get any warnings. Okay, so I'm good. So what this is going to do is going to pull the range out of the input MAL, and it's going to pass that range into the set f real value here, which will ultimately call the alter method for this sensor that's attached to my unit. So it'll call this guy, and we'll see that in there, and we will set the value of max range inside of our object. So it doesn't do anything real, it's just illustrating how to call the alter method for a sensor. So we're almost done. The next thing we need to do is we need to actually set the prototype of this cognition model up. We have to have a prototype in order to be able to call it, because the prototype is what tells Flames that this particular process method exists. And we have to define that prototype such that this particular input value is a required input value for this process method. So I'm going to go to my Flames launcher, and I'm going to run the model prototype editor. So I've got it right here, and I'm going to open a model prototype file, and I'm going to navigate over to the build folder in my project folder and into the F tutorial project, and then down into F cognition and EXM cognition. And here's the model prototype file for this particular class. And we've looked at this file before. So I'm going to add a new prototype for this new method that I just created. So here's F EXM cognition assess, and I'm going to take that and I'm going to use that to copy, and I'm going to call this set sensor range, which is the same name as my my method. Now, as we've talked about before, you don't put the colon This is the name of the prototype, and the name of the prototype doesn't have 2 colons in it. But we do name it something that's very similar to the name of the actual method, just without the 2 colons. It is a prototype that's a type of process method. It's still the same class. And this, we get to choose whatever command we want. And we're going to just call this set sensor range. And I'm going to make the description of it the same as my comment right here. So I'm going to copy that, and I'm going to paste that in right here. Set the max range of the sensor attached to this unit. And I'm actually going to do something a little bit different. Instead of calling the input sensor range, I'm going to change it to max range. It doesn't really matter. You can name them anything you want. I'm going to copy that value there. And before I continue on, I'm going to go to this particular prototype, and I'm going to hit accept. So I've got my new prototype defined here. And then I'm going to change the name of this input to max range. And it is just like the range value that we passed into the assess method. It is a distance data type. And we're going to leave the distance unit of measure. I'll tell you what we're going to do. We're going to actually use the default value. So it's going to be kilometers, and we're going to say that that's 100 kilometers, just to illustrate how this default works. And then I'm going to say value to which max range of so that's a comment there for my input value. So I think I'm done. So with this, I'm going to save my changes. So that updates the MPP file for my EXM cognition model. It updates that file right there. That's the file that I'm editing. So now I'm going to go back and rebuild the solution. So it made it, I changed that file, so it did a custom build on that. So it compiled the information here and then generated a new version of my CPP file. And I changed the sensor max range and generated the code. So that's the last of our code changes, and we're ready to actually test our new process method. So I'm going to open up Forge. So I'm going to run. And we'll run Forge. And we're going to go open up our same cognition development scenario. So we've got the unit here that we've been working with. And when I say add command, sure enough, my new command shows up. So that's what the prototype did for us. It made Forge aware that my cognition model has a new process method on it. So I can click set sensor range, and there's the description that I gave to it, same in the prototype. So I'll say add and close, and sure enough, there's my max range value. That's the input that I specified. There's the description that I specified. There's the default value and the default unit of measure that I specified. So that's it. That's how easy it is to add a new process method to a cognition model. Of course, you would want to do more than this in here. In fact, I am going to do a little bit more. I want to actually make sure that this particular value worked. So I'm going to add a little code in here. It's not necessarily code that you'd want to put in there, but just to prove that this thing really works, because I don't have any output coming from this at all to confirm that it works. Let me show you how to get a little bit of output here. Now, first of all, this test on the return value of f entity set real value is not really necessary. It's not bad to leave it in there just in case somehow the sensor changes. But if you have properly kept up with the interface of this particular sensor class, and let's go back and take a look at that. We said that the name of the interface supported by this sensor, when the sensor class is initialized, we call this example sensor. So if we're keeping up with that and we are making sure that that interface is defined such that the attribute method supports max range, and we know that, well, then we're going to get a successful return value from this. And also I want to point something out here. This is not uncommon. If an alter method doesn't support a particular input value, as is the case here, let's say we typed in, we spelled max range wrong. We would go through this loop, we would never find an argument that we recognized, and we would just return success. So if an argument happens to be in here that is not recognized, this particular method does not return something other than success, and it doesn't print out any kind of warning message. You could write models that put a warning message out there. Normally we don't do that because we're being careful to make sure that our interface is well defined, and the model that implements the interface, which in this case is the sensor, and the model that uses the interface, which in this case is EXM Cognition, that they're in sync. So the call that we make to set the value is, I'm sorry, it's not configured on unit, it's a set thing, and there's not a reason to test that because, again, we know that the sensor supports our interface. So I'm actually going to take that off because it doesn't return an error in any case anyway. Now, what I am going to do, though, just for testing purposes, is I'm going to make sure that the range actually got set to the value that I specified. So for testing purposes, I'm going to make another call here, and I'm going to make this a call to get fReal value. And I have to pass in the address of max range. And I'm going to say get the range to confirm that it was set correctly. So I'm going to say max range equals 0. Then I'm going to do the call to get, and then I'm going to add an FMH print. And I'm going to pass in 2 zeros, and then I'm going to say max range set to. And I'll take this out. So now we set the value, we set it to 0, and then we go back and get it. So the value we're going to get back is the value from the query method. So that's what this guy calls is the query method. And remember, in the assess method, we queried for first target ID. So I'll open up the attribute method again and go down here to query. So we queried for first target ID, but this query method also supports max range. So it'll take the value of max range and return it through the argument list, and we'll get that returned to us in this call to get fReal value. So now let's build our solution. Everything built fine. So I'm going to run Forge again. And we will open our scenario again. And our scenario has back behind the scenes, I forgot to save this scenario before I closed it. So let me add that set max range in there again. And I will accept and save the overall scenario, so it'll be there that time. And now I'm going to run it, and we'll pause. And right away, so here is the, let's see where it is. There's the value right there. Max range set to 100,000 meters, which is 10 kilometers. So that's the output that came there. Again, we're just doing this for debugging purposes, just to make sure that it works. And as long as we're attaching a sensor that has the right interface on it, which we check in our configure on unit, then we're going to get this value. So I can actually go in here now and take all this code out of here. So very simple process method. Obviously, in a real process method, we'd be doing a lot more inside here, but I just wanted to go through the steps to show you how to create a new one, and then no matter what kind of process method you need. So as you can see, it's very simple. There's one thing that I would like to show you before we end this video, and it has to deal with what we think is a bug in Visual Studio. We haven't been able to figure it out. It's the same bug that we mentioned when we were talking about editing graphical user interface template files. And we have a custom rule defined for FMPP files for compiling those to generate the code for the CPP file, the corresponding CPP file. And sometimes that rule will not compile. So I'm going to illustrate that for you. I'm going to go here to the file that we were using to edit this sensor, this set sensor range process method prototype. I'm going to save it, so I've made a change to it, and I'm going to go back to my Visual Studio solution, and I'm going to build, and you see it didn't build anything. So this is the bug. If the only change you make to your project is a change to an FMPP file, a Flames model prototype file, that's the only change you make, and then you build the overall solution, it doesn't recognize that that change has been made. So watch what happens if I just make any old change right here, and I save this file, and then I build. So even though there's no real change there, look at my output from my build. It did fire the custom build rule for that file. It did build, so I got a new CPP file, and then it compiled the file that I just changed. So if I change any other file in my project at the same time that I changed the model prototype file, it will pick it up and it'll build it. But if this is the only change I make and I build, it doesn't pick it up at all. So you just need to pay attention to that. That's a little quirk in Visual Studio. One way to get around that is to go ahead and make a change in another file, or you can right click on the FMPP file and say compile. So that will do the custom build step, force it manually to do that, and then when you build the solution, it will compile the CPP file that got generated by that custom build step, and you'll be good to go. So that's a little quirk. We have not figured out how to define the custom rule in a way that makes Visual Studio pick it up. We think it's a bug in Visual Studio. If you happen to figure it out, you can let us know. I would greatly appreciate it. So that concludes this lesson. Thank you for watching, and thank you for using Flames.